are two different types of refractive index. One is relative refractive index, another one is absolute refractive index. When it is observed from different angle, the incident light passes from this edge, it passes over here. That is traveling from denser to rarer. If you get any refracted ray to be 90 degree at an angle, that means your angle which was incident is called as a critical angle. Hello everyone, I am Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to Session 3 of Chapter 9, Ray Optics and Optical Instrument. Today in this class, we are going to study about homogeneous mixtures, heterogeneous mixture, as well as the refracting. We will just introduce a concept which is called as refraction, because in our previous class, we learnt about reflection. So in this class, we are talking about refraction. So first of all, I am talking about the homogeneous mixture. So what is meant by a homogeneous mixture? Homogeneous mixture means it is a mixture in which each and every properties of that mixture remains the same at each and every point. So now there is an example for a homogeneous medium, that is a packet of sugar is dropped inside a glass of water. You just mix the sugar, what happens? You will get a clear water once again, because the sugar has completely mixed within the water molecules, which gives that each and every point of that mixture gives the same properties. Similar way it goes with a cup of coffee or a cup of tea, that is the decoction water is getting mixed with the milk, so that each and every properties after the mixing up remains the same at each and every points. Correct? So similar way we have something which is exactly opposite to that, and that is nothing but your heterogeneous mixture. So by looking at this beautiful yummy picture, what do you exactly feel? That is, there is a picture over here which gives you two different concepts. That is, you have your cereals here which is dipped inside the milk, and you also have your fruits which is laid on the top. Okay, garnished on the top. So when this is a case, is it a homogeneous mixture? Is it the same throughout it? Does it exhibit the same property throughout the mixture? No, because this is not properly getting mixed up. Okay, so that is why this comes under a heterogeneous mixture. That is, each and every point in a mixture will have different properties. Okay, and next coming to the blood. We have red blood cells, we have white blood cells, as well as we have platelets also. So there are three different types within a one single blood. Okay, so that is nothing but your heterogeneous medium. It is different. Okay, and each and every cells over here depicts the different properties. Red blood cells have got different function or properties. White blood cells are also have different properties, as well as platelets also exhibit different property. So everywhere, each and every point on the blood vessel, we have different properties which is enacted. So that is all about your homogeneous mixture as well as heterogeneous mixture. So what is homogeneous mixture? It is the medium whose properties are same from point to point. And what is heterogeneous mixture? It is a medium whose properties differ from one point to the other point. This is all about your homogeneous and heterogeneous mixture. So now, till last class, that is the last session, we had studied about reflection. And now my topic is refraction. So what exactly is refraction? It can be seen with the help of this image. Take a glass of water, dip a pencil or a stick inside it. What happens? You can see that the path has little bit shifted away from the original path. That shifting of the path, refracted ray, this is called as a refracted image. The shifting up of an image is known as refraction. So what is refraction? the shifting up of the incident light or the incident ray is said to be the refraction. There is a small shift which is taking place over here. So let us see what are the rules which have to be seen in order to have a refraction. So now we have a glass slab. If suppose this is a glass slab, the air or vacuum condition can be called as a rarer medium, and the object which is placed, that is called as a denser medium. So now a ray of light from an object is passing through from rarer medium through intercept in order to enter the denser medium. So a ray of light which passes from rarer medium, this is the incident light. Here we just draw a normal to the surface of an object. When it travels inside, that is inside the denser medium, it is always towards. So the line bends towards the normal. So when the incident light is incident on the surface over here, that is the interface, this is a normal, that is the imaginary perpendicular line which is drawn to an object. So when the ray of light is incoming, it just bends towards your normal. So this is towards the normal. Okay. So if you just have exact original path can be drawn in this dotted lines. This is the original path of it, but it has not swept the original path. It has taken some other different path by deviating itself. So this angle is said to be angle of deviation, and normal, between normal and refracted ray, it is said to be angle of refraction, and this is angle of incidence. So what does your first law of refraction tells? It tells you that the incident ray, the refracted ray and the normal drawn to the surface all lie on the same plane. It is the incident ray, the refracted ray and the normal which is drawn to the surface of an object all lie on the same plane. This is one single plane. That is your first law, same copy paste of your law of reflection. The first law of reflection as well as the first law of refraction comes to be the same thing. So if you learn one, the other thing also, it's the same thing which you can drop it in your paper. So coming to the next one, here we are talking about a law called as Snell's law that comes only in case of refraction. So what is meant by a Snell's law? Snell's law means you just use this Snell's law in order to give the refractive index. So what is that refractive index? Refractive index is the one where we measure the speed of light, because the speed of light is different in case of air or vacuum, or it is also different in case of some other different object or the medium. So how you give the Snell's law? Remember, the second law of refraction is nothing but Snell's law. So what is Snell's law? Snell's law means so we have Snell's law given as Snell's law is all about the refractive index, what you're talking about. So the ratio of sine of angle of incidence to the sine of angle of refraction is said to be your Snell's law. Only by looking at this equation, you can give the Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is said to be a constant for a given pair of medium as well as for a given pair of a color. It depends on your medium or a color. So suppose if a light ray is traveling from rarer to denser, call this as N1 and this as N2, from rarer to denser. So this Ri can be written as in case of two types, from rarer to denser, or if it is from denser to rarer, it can be written as denser to rarer. This is how you write the refractive index, which is given in terms of N. So these are the two laws of refraction, which is very, very, very important. So here there are two types of refractive index. I told you refractive index means it is a measure of speed of light in vacuum or air or in case of the medium. There are two different types of refractive index. One is relative refractive index, another one is absolute refractive index. So what is this relative and what is this absolute? Relative means there is someone who is also related to you. That means they are your family. So you just compare yourself with them, correct? So that is nothing but a certain relationship. You are someone and they are someone to you. They are related to you in too many other ways, correct? So here relative means you're relating one thing with the other. So here relative refractive index means you're relating the refractive index of one medium with respect to the other medium. Coming to the absolute refractive index, it is absolute, it is a standard one. That is, you're relating a refractive index with respect to that of a vacuum or air. That will be your absolute refractive index. So this is all about your refraction, refractive index, angle of incidence, angle of refraction, and what is angle of deviation. Angle of deviation means from the refracted ray, how much is the original path? What is the distance of that original path? That angle is said to be your angle of deviation. Coming to the next one which has to be followed up, that is, suppose I told you if the incident light is moving from the incident ray to the refracted ray, it moves towards the normal. That is, the bending of the refracted ray is towards the normal. Suppose if it is moving from denser to rarer medium, the bending up of the ray has to be away from the normal. Suppose if I consider a ray like this is a denser medium, this is a rarer medium. So after the surface drawn, there is a normal which is to be drawn over here. So the incident light is nearer here to the normal line in case of the denser. So when it comes to the rarer medium, it moves away from the normal. So here you have a wide gap between the normal ray as well as incident ray. So this is a refracted ray. So there is a wide gap between the incident as well as the refracted ray when it flows from denser to rarer. So I hope you got this concept, how exactly the refraction takes place, because of which these two images are the result of your refraction. Next, we are coming to consequences due to the refraction. So what are the consequences present due to the refraction? Call it as a lateral shift. So what is meant by a lateral shift? Lateral shift means there is a shift from exactly the path of the incident ray as well as the refracted ray, which I had called as angle of deviation, but we don't give the angle of deviation, we just measure its length. So suppose here there is a surface, there is a normal which is drawn to the surface, and the incident ray, suppose this is a rarer medium, denser medium, the incident ray is incident on the surface, so it makes an angle I. So the incident ray, it makes an angle I with respect to that of a normal. So how exactly it moves in case of denser medium? I told you from rarer to denser means the refracted ray bends towards the normal. So towards the normal gives you this part. Okay. So if this is a cubic glass kind of a structure, so this is your refracted ray, call it as angle R over here. And now give a imaginary path to the original path, that is this path, incident ray. So just put a dotted lines. So it has shifted so much. So from here to here, this distance is called as a shift. There is a shift from the incident original path towards the other side. So it is called as LS, means it is a lateral shift. LS is equal to T divided by, so this is the T means it is called as thickness. It is the thickness, and we have the equation cos R into sin I minus R. So this is the equation of the lateral shift. So coming to the next part, that is same, under consequences due to refraction, we have something called as normal shift. So what exactly is the normal shift? Suppose you know the depth of a area or a depth of water. there an object, or suppose you consider a coin which will be fallen, okay? In your holy places, you might have observed you just dropping a coin inside a water-contained reservoirs, correct? So inside that you will drop a coin. When you see from up, how can you exactly see the coin? As if it has come a little above. That is, it's supposed to be, or it seems to be reaching you. Okay, so that is how exactly you observe a coin which is inside the pond. But actually, the coin which is placed inside the water is at certain depth. Okay, actual depth is something else, and the depth what you observe is something else. So that is nothing but your normal shift. So how do you do that? So there is a denser medium. Actually, there is a coin which is placed over here. Consider this as an object. So now your incident ray travels from denser medium to a rarer medium, that is from water towards up. Okay, so it is from your denser medium to a rarer medium. So suppose if you have a normal which is drawn over here, and the incident light, when observed from here, it seems to be at the bottom itself. The depth also doesn't change. So this is the original depth, call it as T. Suppose you observe from any of the angle. When it is observed from different angle, the incident light passes from this edge, it passes over here. That is traveling from denser to rarer. So when you just have a normal which is drawn to the surface, when a ray of light travels from denser medium to a rarer medium, it shifts away from the normal. So it is away from the normal over here. So this will be your refracted ray. This is your incident ray. And the original path, let us just put a original path which is drawn to it. So here we had considered the previous case, we had considered about the lateral shift when it travels from rarer to denser. Now we are considering about the normal shift. That means at this point, call it as I. If this is O, that is object which is placed, I means it is the image what is formed. So when you observe from this angle, you feel that there is I, that is the image which is just shifted above. This is called as apparent shift, or else it is also called as this normal shift. It is called as apparent, or it is also called as normal shift. So that is all about your consequences or due to refraction. One is lateral shift, other one is your normal or the apparent shift. So there is a set of equation for this, and that is nothing but NS, normal shift, is equal to T into 1 minus 1 by N is the final expression of this normal shift. So I hope you are clear with the equation of the normal shift as well as the equation of the lateral shift. Okay, so now we are moving on to the next topic, and that is under the same consequences usually we see the atmospheric changes. That is, why does the sun appear reddish in color early in the morning? How exactly it appears before the sunset or the sunrise? So all that is due to the atmospheric refraction or the refraction through atmosphere. You can see these atmospheric layers are present over here, right? So this acts as a material which is, or the medium which is used for the refraction. So the light rays which is coming from the sun, okay, exactly it is the original position of the sun. So this original position of the sun before crossing the horizon, it just undergoes too many deviations, that is refractions, because of which the apparent position, when you just mark a dotted line, we feel that the sun is present at this position. But the exact position will be too very far away from the apparent position. The same thing goes up with the stars as well. So here you can see stars, number of stars which is twinkling, correct? So here also the stars has got no exact position. The position whatever you see of the star is nothing but the apparent position and not the exact position. Why is that? Because of the number of refraction which it undergoes. Same thing goes up for the twinkling also. The twinkling of the star is also due to the enormous amount of refraction which it takes up when it passes from one layer to the other layer, because the medium is too very different, because it travels along too many denser mediums. Okay, that is why we call this as atmospheric refractions. That is, one is your sunrise and as well as sunset, and another one is twinkling of the stars. So these two concepts also comes under the consequences of the refraction. So coming to the next topic, that is total internal reflection. By looking at this pictures, what comes in your mind? So here we have two images. That is, one is the heated road. Okay, so during your hot summer days, when you just move in a highway, okay, you just get this visualized picture. That is, you feel that there is a presence of water. If you have not observed, once during the summer days, you can observe it properly. So there is a water content on the road. That is a sensation what we feel, there is a water content. But exactly when we reach that spot, there won't be any waters. So the first of all, what you know, the example, what you clearly know, very familiar to the example, that is oasis in the desert places, correct? So you feel there is a mirage, it is called as mirage. So there is a feeling that there is a presence of water, but there is no presence of water. Why is that? That is, when there is a presence of hot summer days in a hot region, the ground layer is too very hotter than that of the above layers. There are too many layers. Okay, so it is like, suppose if there is a coconut tree over here, and there is a desert land over here, and there is a person who is standing over here. So any light rays which is falling from the tree, it has to cross many layers, and the layer which is below is said to be too very hot, and as it goes up, it is too very cold. So the light rays, when it travels from, suppose if this is a denser, towards the rarer it is traveling. So what happens? From denser to rarer, it keeps on moving away from the normal. So your light rays will be something around like this. And when it passes from rarer to denser, that is from rarer to denser medium, somewhere it arrives to be like this. But the actual path of this line, that is the mirage, can be seen over here, and there is a presence of a pool or a reflection. The reflection of the images, that is trees and all, make us feel that, oh, the object is getting reflected. That means there is a presence of water. So that is why we feel a mirage event in our daily life during hot summer. So it has to cross too many layers, that is cooler parts, and finally it reaches the hotter part. Finally, from there, it gets reflected towards ice. First, it undergoes refraction, then it has to undergo reflection. When it undergoes reflection, we observe a reflection that is called as a total internal reflection. So this is one of the main event which occurs due to total internal reflection. So, example you have studied. Now it's your duty to understand what exactly is total internal reflection. How is the ray of light? So the value of ray of light should be equal to which angle, so that we get the total internal reflection. The word itself says total internal reflection. That means the complete rays which is about to get refracted, it reflects back internally. That is, you have a barrier over here, whichever light rays is traveling. So there are two set of rules which is very, very important in order to maintain the total internal reflection. The first rule is the light ray, that is the incident light, has to travel from denser to rarer medium. So this is one of the most important questions which will be asked, conditions for total internal reflection, and that is too very important. So what are the conditions? The first condition is it travels from denser to the rarer medium. So suppose if there is an object which is placed over here, okay, probably a glass slab. Suppose a ray is incident on a object in this way. You can just consider a normal which is drawn to the surface of it. And there is a normal drawn to the surface at the point of incident. When the ray travels from denser to rarer medium, the ray, it moves away from that of the normal. So, how does the ray move? In this way. And again, if your ray is incident in this way, there is a normal which is drawn to the surface. So, it is giving a deviation, it will be a complete deviation. I can just call this angle as a critical angle. Critical angle means if I is equal to C, if the incident angle is equal to certain angle called as a critical angle, that means your refracted ray has to be at 90 degree from the normal. If you get any refracted ray to be 90 degree at an angle, that means your angle which was incident is called as a critical angle. So, for every critical angle, you have angle of refraction to be at 90 degree. Okay, so your first condition is, in order to have a total internal reflection, the angle of your incident ray should be greater than that of the critical angle. That means it has to be greater than the critical angle so that everything will get reflected back towards your slab or the glass slab, whatever you're taking over here. So, the incident ray is greater than that of a critical angle. So, it is greater than this angle. So, you have a normal which is drawn to it, but it gets reflected backwards. So, that is all about your total internal reflection, what I was talking about. The same process is happening in case of the previous images, whatever you have studied. So, what is your first condition? That is the important question which will be asked. Give two conditions for the total internal reflection to take place. The first point is like, always the incident ray should travel from denser medium to a rarer medium. That is your first point. So, there you will have your 1 mark. The second point is the angle of incidence should be greater than that of the critical angle. So, these are the two set of points for which you will carry 2 marks, and this is nothing but the total internal reflections condition, which is very important. So, in today's class, we have studied about what is meant by homogeneous mixture, what is meant by heterogeneous mixture, and finally we have ended up with refraction, consequences of the refraction, and total internal reflection, which has got the series of, that is, refraction and reflection concepts. So in our next class, let us have something more about the same chapter, that is chapter 9, ray optics and optical instruments. Until then, have a good day. Thank you.